Working with sector coupling solutions, I'm of course most interested in the energy flows. Can you explain to us what we're showing here in terms of the smart store?
Yeah. What we do see here is all the different applications in our small supermarket. And starting on the top, we have 100 kilowatt of solar panels installed on the roof. We have two CO2 pack systems installed, or rack systems that you call them. One which is a standard system, which is specified by COOP for such a small store like this one. And then we have a second pack, a little bit more advanced one, where we have all the technology that actually can be used more or less all over the world. We have the evaporators at the cold rooms in the store, like in a standard store. So we are doing the operation of a standard supermarket. We connect it to the electrical grid, so we can buy electricity, but of course we can also sell electricity if we have too much. We have an external district heating grid, so we are actually getting all the heat needed for the building. We can buy that from the district heating. But we can also send back or sell back energy to the district heating if we have excess heat, which we do have in summertime. We have a ground loop out here in just next to us, so we can take out about 20 kilowatt of heating capacity from the ground. So what we do, we connect that ground loop in the same way as the cabinets are connected. We connect that to the refrigeration system. Because in winter time there's not enough energy or heating in the goods for us to heat up the building. So then we have extra heat from the ground we can take out, connect to the refrigeration system, and in this way we can actually produce a lot of heat even in the winter time. We can do de-icing in front of the building. We have lots of components from our heating division for optimizing hydronic flow, which is also extremely important to optimize such a system as we have here. We have car charging, which we need to have by law. We also have prepared for a fast charger. So if I had a Tesla, one of the bigger ones, this one car would take 3 times more energy than the whole building here running peak, 3 times more. And that means going forward, we will be asked to deactivate energy capacity very fast, because when all of us are driving an electrical car, our grid system cannot do it. There's not enough capacity for all of us to charge at the same time, and therefore the whole industry will be asked to be able to deactivate energy. Also, with all renewable energies we see here, with the windmills and solar panels, that's also a stress factor for the whole energy system. We have not yet installed a battery. It's on our plan. It will be done this year. We have some cold water for air conditioning, comfort cooling, and some also a little bit buffer for hot water and lighting control, heater control. So all these are the energy streams we are actually going to optimize. But why don't we go inside and take a look at all the technology and see how it works in practical?